Hello everyone, my name is Harshita Pawar and today's my presentation topic is critical path method using forward and backward pass computation. Now let's see introduction of CPM. What is CPM? CPM, the main definition of CPM is a critical path is a sequence of activity between a project starts and the finish that take the longest time to complete. And critical path method is based on the mathematical calculation and it is used for scheduling project activities. In 1950, critical path method was developed by Kelly and Walker to assist in building and maintenance of chemical plants. The initial critical path method was used for managing plant maintenance project. After that, there are the two pass, forward pass and backward pass. The early start and early finish time calculated by moving forward pass and consider it maximum. Then the backward pass, the latest start and latest finish time calculated by moving backward through the network, considered minimum. Then steps in a critical path method. First, make a forward pass through the network as follow. For each activity I beginning at the start node compute, then we can find the earliest start time and the earliest finish time. What is the earliest start time? The maximum of the earliest finish times of all activities immediately preceding activity I. This is a 0 for an activity with no precedence, predecessor. This is the earliest time an activity can begin without violence of an immediate precedence requirements. Then earliest finish time, earliest start time plus time to complete activity I. This represents the earliest time at which an activity can end. The project completion time is the maximum of the earliest time and earliest finish time at the finish node. Then we can see step 2, make a backward pass through the network as follows. Move sequentially backward from the finish node to the start node at the given node J and consider all activities ending at node J. Then for each of these activity I, J compute latest finish time LF. The maximum of the latest start time begin at node J and this is the latest time of an activity can end without delaying the entire project. Then latest start time, latest finish time minus time to complete activity I, J. This is the latest time an activity can begin without delaying the entire project. Then step number 3, calculate the float time for each activity by float is equal to latest start minus earliest start or latest finish minus earliest finish. A critical path is a path of an activity from the start node to the finish node without zero time. So this is the example. Construct the CPM network using the detail below and determine the critical path. These are the activities which are the A, B, C, D, E, F, G. These are the immediate predecessor and completion time. Then the total completion time is given here, which is 28. Now this is the activity diagram. You can see here 0 is the starting time we can take, and we can take first activity as an A follows B and C, and also C follows D follows E, and B is also follows E, then E follows F follows G follows nobody. So this is the last activity. Now here we can see the upper time is given above the line is the latest start duration, and this is the uh, uh, this is the starting time, and this is the latest finish time. Now here from this we can calculate the for each activity latest time and finish time by using forward and backward. Let's see how it can done. First we can take 0 as an latest time, then 0 plus 2 for activity plus 2, it is 2 latest time or starting time, then 2 plus 3 5 for activity C, then 5 plus 4 D. For D, 5 plus 4, 9, 9 plus 8, 17. And but here for activity E, there is a 2 times uh, are given. You can see from B's is a different and from E is a different, but we can from 3 plus 2 is a 5 and here it is the 17. We can take the max time for the forward pass. It is 17 plus 6, 23, 23 plus 2, 25. For backward pass, we can take the minimum time. Then 25 minus 2, 23, 23 minus 6, 17, 17 minus 3, it is 15. But we can take minimum time so that we can choose this path. 17 minus 8, 9. Likewise, it will happen. Then this is the chart. We can here we can form a chart. These are the activities time earliest start. We can in activity diagram we can find out the earliest start and the latest finish, which can be written from there. Then earliest finish we can find out by earliest time plus duration time, so that 0 plus 0 minus plus 2, 2. Likewise, 2 plus 3, 5. 3 plus 2, 5. And latest start is a latest finish minus time, which is 0 minus 2, which is 2 minus 2 is a 0. 17 minus 3 is a 14. 5 minus 3 is a 2. Likewise, it is find out. Then latest finish we can take from there. Then slack is the latest start minus earliest start, which is 0. This is the latest start and this is earliest start. Latest start minus earliest start. 0 minus 0, 0. 14 minus 2, 12. So here we can see, we can write here the critical path. Likewise, it follow. And here we can see critical path are written. Yes, when we can write the critical path, when the earliest time and the latest time both are the same, for that activities we can write S. Critical path is S, and otherwise we can write no. This now we can see how it will shown in activity diagram. So this is the critical path which will be shown by double line from the table. And the critical path, how it will be find out. Critical path is equal to, we can add the all the activities inside it and their duration. 2 plus 3, 3 plus 4. A to C distance is a 2, C to D is a 3, D to E is a 4, E to F is a 8. Likewise, all distance are added here and the total is a 25. This is the critical path. Thank you.